We've decided that the most important part of this chapter was proofs, as we continually use them throughout geometry. Proofs are used to show that specific statements are true with previous known knowledge. In all proofs, there is a given and a proved statement. The given is information you already know about a specific diagram. The proved statement is what you are trying to say is true. In this diagram, we are given that the angle FGJ is congruent to angle JGK, and that the angle JGK is congruent to angle KGH. We are also given that the measure of angle FGJ equals 6x plus 7, and the measure of angle KGH equals 8x minus 5. We are then told to prove that x is equal to 6. There are several different ways to go about making a proof. One way is the two-column proof, in which you draw out two columns, one being the statement and the other the reason why you made the statement. So we will show you how to do this proof step by step. The first thing you write down in any proof is the given information, so that if even someone didn't have the diagram, they'd still be able to see that the proof works. So in a two-column proof, we will put the given information on the left and the reasoning on the right. For the given information, we just write given as our reason. Now we have to use other things we know in order to prove that 6 is equal to x. We need to use things like postulates, theorems, definitions, and properties. The next thing we are going to say is that the measure of FGJ is equal to the measure of JGK, and the measure of JGK is equal to the measure of KGH. Next, we will say that the measure of angle FGJ is equal to the measure of angle KGH. This is because of the transitive property of equality. It states that if angle 1 is equal to angle 2, and angle 2 is equal to angle 3, then angle 1 is equal to angle 3, as they are equal to the same thing. The next statement that we make is that 6x plus 7 equals 8x plus 5. We are able to say this by the substitution property of equality, as 6x plus 7 equals FGJ and 8x minus 5 equals KGH. Our next step will be to add 5 to both sides of the equation. We are able to say this by the addition property of equality. Next, we say that 6x plus 12 equals 8x by the substitution property. Now we can subtract 6x from both sides by the subtraction property of equality. Now we can say that 12 equals 2x by the substitution property again. Then we divide both sides by 2, and we are allowed to do this by the division property of equality. This then becomes 6 equals x by the substitution property of equality. Finally, we have to make sure that our statement matches the proof statement exactly, so we need to say that x equals 6 by the symmetric property of equality.
We've decided that deductive reasoning was the most difficult subject, other than proofs, in this chapter. Contrary to inductive reasoning, which uses specific examples, observations, and educated assumptions, deductive reasoning uses facts, definitions, and in the case of math, postulates and theorems. A proof is an example of deductive reasoning. In deductive reasoning, there are two main laws, the law of detachment and the law of syllogism. The law of detachment states that, as long as the facts given are true, the conclusion reached using deductive reasoning will also be true. The book puts it as follows. If P then Q is a true statement, and P is true, then Q is true. For example, if a car is out of gas, then it will not start. Sarah's car is out of gas. Therefore, Sarah's car will not start. The law of syllogism is much like the transitive property of congruence. It states, if P then Q and Q then R are true statements, then P then R is a true statement. For example, if you get a job, then you will earn money. If you earn money, then you will buy a car. Therefore, if you get a job, then you will buy a car. These laws both make up deductive reasoning.
For our third choice, we chose inductive reasoning. Inductive reasoning is assuming conclusions from a series of logical assumptions. The result of your assumption is known as a conjecture. Simply put, a conjecture is your conclusion reached through inductive reasoning. Inductive reasoning can be used to either approve or disprove a hypothesis. For example, if you think that the sum of any two odd numbers is an even number, first you would list examples such as 1 plus 3 equals 4 or 5 plus 9 equals 14. After multiple examples, if you begin to see a pattern, then you create a conjecture. Because you have realized that the sum of any pair of odd numbers is even, then your conjecture would be the sum of two odd numbers is an even number, or something similar. To disprove a hypothesis, you need a counterexample. A counterexample is a statement that shows a scenario or any possible way in which the conjecture doesn't work. For example, if n is a real number, then n squared is greater than n. The counterexample to this would be, when n is 1, the conjecture is false, since 1 squared is not greater than 1.
I just wanted to say thanks. I'm glad you came along, partner.